I want to talk about three primary characteristics of a wave. Now, this could be a physical wave or an electromagnetic wave, but we're going to use all three of these characteristics in how we encode information into waves. And so in digital communication, these are electromagnetic waves, but the characteristics are true of either type of wave. The first is amplitude. Now, amplitude simply means the force of the wave, how powerful, how much energy is in that wave. And we represent the very high energy by these very tall waves and low energy by these very short ones that you see coming along in between. So that is the amplitude. And by varying the amplitude, we can encode information into this wave. The second is frequency. And here we have a high frequency, and down here we have a low frequency. Let's take a look at a static version of it and make another point about frequency. Here's a static version of it. So here I have a low frequency, and over here I have a high frequency. The extra point that I want to make about this is that there's also something called the wavelength, and the wavelength is not a primary characteristic of a wave. It is a manifestation of the frequency. And you can see that here. As the frequency gets bigger, the wavelength gets smaller. Here I've got a low frequency. In other words, I don't have these crests and troughs happening as often in a given period of time. So I have a low frequency, but a very large wavelength. I've got a long space from trough to trough here. I have a very long space. So I have a large wavelength with a low frequency. With a high frequency, you have a small wavelength. So here's a high frequency, and you can see I don't have much space between these two adjacent troughs. So wavelength is not a primary characteristic. It is another manifestation, the inverse manifestation of frequency. The third primary characteristic, we've got amplitude, we've got frequency, and the third one is the hardest one to understand, and it is the phase of a wave. Now here's the animation, and you can see that I've got three waves here, a green one, a blue one, and a red one, and they are all in different phases. So what do we mean by phase? Well, let's take a look at this static diagram, and I'm going to take this picture and move it out of the way here. The static diagram here shows us a wave in different phases, and by that we mean where is it in terms of its cycle. This being one cycle, by the way. A cycle starts here at neutral, at 0. It rises, it goes back to 0, and then falls and goes back to 0. That is one cycle. One rise and one fall. So that's a complete cycle, because that's where it starts repeating again. Another rise, another fall. We look at where the rise is and where the fall is with relation to time. So here in this one, we call this a 0-degree wave. Relative to a point in time, and we determine what that point is, this wave begins to generate and begins its rise and then its fall at that point in time. However, if we have a second wave, this orange one here is at 90 degrees. If that begins at the same point in time at the top of the crest here, then we would say that this is 90 degrees out of phase. And when we say out of phase, we say with relation to a point in time or with relation to this first wave that we called 0. All right? So, by the way, we could call any of these 0 if we just change that point in time. If I'm looking at the red one, for example, and I started at this point in time as my 0 point, then this is 0 degrees. But these are all out of phase with relation to each other or with relation to that given point in time that I choose. So a 90 degree is at the crest at that point 0 in time. A 180 degree, the green one, is back to the 0 point, but changing directions. In other words, here the green one, it's going down at this 0 point rather than up like the blue one. And then 270 degrees is this red one. It starts at point 0 at this point in time. So we can change phase. I can create a wave such that, say we go from this blue one here and tracking it, and then all of a sudden I switch it and I start this rise again as in this green one. I have just changed phase of that wave. So we can manipulate all three of these. We can manipulate the amplitude, the frequency, and the phase. And by manipulating them, I can encode information into those waves.